Okay, this is test review for chapter 10. Okay, number 1 says match the appropriate description for the domain and range of the given function. So, given the function f of x equals x squared plus 1, we can graph it to sort of get an idea of what it looks like. So if you put it in your calculator and graph, you'll see that the vertex is at 1, and it's a positive quadratic, so it's facing up. But remember, we actually didn't need to graph it for the domain because a parabola or a quadratic function is going to have a domain of all real numbers. The range is what's going to be limited for a quadratic function. So it's up at plus 1. Remember, range, we're thinking y values. Okay? And notice any point on this parabola is not going to be anywhere below 1. So in other words, the outputs, the y values, are all greater than or equal to 1. So B. Okay, if this were a negative function, something like this, y would be everything less than or equal to 1, because the outputs, the points on the parabola, are not going to have y coordinates anywhere above the 1. Okay, so it sort of just depends on the situation. If it's a positive parabola, though, it has a minimum value, then its y is going to be greater than or equal to that number. If it has a maximum and it's a negative facing down, it's going to be less than or equal to that number. Number 2, what are the other 3 names for a solution of a quadratic equation? So remember, you might also hear them called roots, zeros, or x-intercepts. And it all means the same thing. They're all asking for solutions, or in other words, they're asking where does this function cross the x-axis. Okay, and then also remember, a quadratic will either have 2 solutions, 1 solution, or no solution. So it's either going to cross the y-axis twice, the x-axis twice, it's going to have a vertex on the x-axis, meaning it only has 1 solution, or it's not going to cross at all, in which case it has no solution. Okay, number 4, what are the roots of the equation 3x squared plus 5x plus 1 equals 0? Now, this is one of the few times where factoring or calculator or anything like that is not going to work, because the answers haven't been simplified all the way, and they've actually left it as the quadratic formula. So you can either use process of elimination, or you can set up the quadratic formula and see what you get. So first of all, to do that, I need to know my A, B, and C. Okay, A is 3, B is 5, and C is 1. Remember the coefficient of the squared term, the x term, bx plus c. And then, why don't I go ahead and plug it in. Okay, so remember my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so remember a is 3, b is 5, and c is 1. So negative b, negative 5, plus or minus the square root of 25 minus 4 times 3 times 1 all over 2 times 3. And actually, I can keep simplifying, but from there, you can already eliminate b and d because it has to be negative 5, so it can't be those. Okay, and then also from there you already know the answer because 2a has to be on the bottom. 2 times 3 is 6, not 2. So it has to be letter C. But if we kept simplifying, you would see that you get negative 5 plus or minus 25 minus 12 is 13 over 6. Okay, for 5 through 8, you could either put it in your calculator or you could do it algebraically. So, since I can't show you the calculator on here, I'll do it algebraically. So for number 5, it's already equal to 0, so I can go ahead and factor. So factors of negative 12 that add together to give you negative 4 would be x minus 6, x plus 2. Alright, and then remember you're going to set each side equal to 0. So you get x minus 6 equals 0, x plus 2 equals 0, and then x equals 6, and x equals negative 2. Number 6, there's no c, but I can factor out the greatest common monomial factor, which would be an x. So if I take out an x, I'm left with x minus 8 equals 0. Set each side equal to 0, and you get x equals 0 and positive 8. And again, you can graph this in your calculator and double check that that's where it crosses the x-axis. Number 7, notice is not equal to 0, so the first thing I have to do is move that 7 over. So I get x squared minus 6x minus 7 equals 0. This is also factorable. I get x minus 7, x plus 1. So my solutions are positive 7 and negative 1. Okay, and for all three of those, you also could have used the quadratic formula. That would have worked just fine. For number 8, though, we're not going to factor, because that would be pretty messy. So instead, remember, the bx term is missing, and when that's the case, it's easiest to use the square root. And to do that, I want to get x squared by itself. So I'm going to add 20 to both sides. I get 4/5 x squared equals 20. Then I want to multiply by the reciprocal to get x squared by itself. Okay, and you get x squared equals 20 times 5 is 100, divided by 4 is 25. Take the square root of both sides, and you get x equals plus or minus 5. And again, you can graph all of those in your calculator to double check the solutions. Alright, this one is factorable. We're looking for the solutions. And you could factor by doing slide and divide. Just so that we can see one example of the quadratic formula, that's what I'm going to use for this one. Okay, so there's my formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So to make it easier to plug in, I'm going to write a is 3, b is 10, and c is 8. And now I'm just going to plug it in. So I get negative 10 plus or minus the square root. 10 squared is 100, minus 4 times 3 times 8, all divided by 2 times 3. So negative 10 plus or minus 100 minus 4 times 3 is 12 times 8 is 96. Divided by 6, 100 minus 96 is 4, so I get negative 10 plus the square root of 4 over 6, and negative 10 minus the square root of 4 over 6, well, the square root of 4 is 2, so negative 10 plus 2 over 6, which equals negative 8 over 6, which equals negative 4/3. Okay, so then I kind of already know it's b, but then negative 10 minus 2 is negative 12 over 6, which equals negative 2. So I know it has to be b. Alright, number 10, identify each function that has exactly 2 zeros. So one way to do this would be to graph every single one in your calculator and see which ones cross the x-axis exactly twice. Or you could try to factor or solve algebraically, or you could use the discriminant. So remember, the discriminant is b squared minus 4ac, and if it is positive, if it's greater than 0, then it means 2 solutions. If it's less than 0 and it's negative, it means no solution. And if it's equal to 0, then it means 1 solution. Okay. So, first of all, I know it's not g of x, because g of x is going to be a line, and that is only going to have one x-intercept, or 1, 0. So then I can do f of x. A is 9. B is 0, because there is no b of x term. And c is negative 4. So then I can plug it in. 0 squared is 0, minus 4 times 9 times negative 4. Negative 4 times negative 4 is positive 16, and 16 times 9 is definitely greater than 0. So we know that that is going to have two solutions. So I would click that one. H of x, A is 1, B is 4, and C is 8. B squared, 16 minus 4 times 1 times 8. And that's going to give me negative 16. So a negative number is less than 0, so no solution. So I'm not going to click that one. J of x, A is 1, B is negative 8, and C is 16. 64 would be negative 8 squared minus 4 times 1 times 16. 4 times 16 is 64. 64 minus 64 is 0. So it has one solution. Not going to click that one. And then k of x is already factored for me. So I can see that if I were to set each side equal to 0, it would have two different solutions of negative 4 and negative 1. So you should have clicked f of x and k of x. Alright, for this last one, it's kind of like a drag and drop problem. You have this graph that has f of x equals x squared plus 4x plus 3 graphed it with the parabola here, and then the line negative 1/2 x minus 2 graphed with it. So you're just kind of matching the intercepts to the graph. So for the parabola, it has x-intercepts at negative 3 and negative 1. So that would be E and F. It has a y-intercept up here at 4. So that's going to be A, 0, 4. Kind of looks like 3 in the picture, but since that's not an option, we're just going to go with A because that's the closest to it. Now the line has an x-intercept at negative 4, so that would be C, negative 4, 0. Okay, and then a y-intercept of negative 2, so that would be D, 0, negative 2. So remember, a y-intercept has a 0 for the x-coordinate, and an x-intercept has a 0 for the y-coordinate. And that's it.